Hi everyone, today I will be going through chapter 18, which is variation and selection. So this is part 1 of this chapter. I will be going through half of it right now, and I'll go through the other half in my next video. So in chapter 18, variation and selection, the first thing we're going to look into is variation, and let's look into the meaning of variation. So variation is basically the differences between individuals of the same species. Okay, now variation is something that makes us look different from one another. So my friend looks a lot different than me because of variation. She inherited different genes from her parents, and I inherited different genes from my parents, which makes us different from each other. Okay, so now this variation is not only in just humans, but it's also in animals and plants. Now looking into more details, so you have two types of variation. The first one, which is controlled by our genes, okay, and one which is controlled by our environment. Okay, so the one that is controlled by our gene, we have hair color, blood type, gender. Okay, these things, they are genetically unchangeable, like you cannot change them. Okay, genetically you can change your hair color by dyeing it, but when your new hair comes, it's going to be your original color. So that means if you were born with brown hair, you will always have brown hair. Okay, so this is what it means when a variation is controlled by genes. Okay, there's nothing else that can change it. You can never ever change it. Okay, and next is basically the variation which is caused by environment. So the first thing we can look into is our climate. Now, how does climate really affect our variation? So climate kind of just affects our skin tone. Okay, so let's say both of my parents are very light skinned, okay, but I end up being tan skin. Now the reason to that is because I'm living in a country which is always hot. Okay, so I tend to have more darker skin compared to my parents. Okay, now if I were to be living in a colder country, maybe my skin tone would have been lighter than my parents. Okay, so basically, usually in conclusion, usually people who live in colder areas tend to have more lighter skin tone compared to people who are living in hotter areas, because in hotter areas you have more UV radiation. Okay, you receive more UV radiation from the sun, which causes more melanin production. Okay, which basically is responsible for your tanner skin. So climate, okay, in conclusion, in short words, affects our skin tone. Okay, next we have physical activities and diet. So basically these two things affect our weight and it affects our height. Okay, so if you were to eat more and move less, then you will have more weight than your parents. But if you were to eat less and move a lot more, you would have lighter weight. Okay, similarly, if you were to have more protein intake in your diet, you are more likely to have a taller height. Okay, so now let's look into continuous and discontinuous variation. Okay, so the first thing we will look into is continuous variation. So in continuous variation, both genes and environment contributes to our variation. Okay, so this is our genes, our environment, it contributes to our variation, and these happen between two extremes. Now what exactly is two extremes? So two extreme is basically a range. Okay, now let's say, okay, over here we have example of height, body mass. So let's take height as an example. Let's say, okay, over here this is your mom, who is 150 centimeter. Okay, this is your mom, and over here this is your dad. Okay, he is 160 centimeter. Now you're more likely to have a height between these two range. Okay, so this is going to be your height range. Now your genes will not determine your exact, you cannot find out your exact height just from your DNA. Okay, because this is a continuous variation and it just depends on your lifestyle, your environment, okay? These two things really contribute to what your height is going to be, but this is your estimating height, which could be minimum of 150 centimeter to maximum of 160 centimeter. However, if you have more good nutritional diet, then you might actually even exceed 160 centimeter, okay? But this is basically your range, okay? When there is a range in any type of variation, that variation will be a continuous variation, okay? So too extreme in keyword that I like to give this is basically range, okay? This over here is your range, okay? Now, oh my bad, okay. Now, one more thing to remember is anything that can be measured on a scale would be continuous variation, okay? So your height and your body mass, okay? These can be measured in scale, okay? That means this is a continuous variation. Now, over here you can see a graph. Now, what does this graph exactly do? So this graph over here is called histogram, okay? This is called a histogram. Okay, so whenever sometimes in our paper they might ask us to draw a graph, they would give us a table of continuous variation features and then they would ask us to make a graph. Now the type of graph we make really matters. So in continuous variation we can only draw histogram. Always only draw histogram. If you do not draw the histogram but you have like a bar chart, let's say, then you will not get your mark. Usually people get confused between histogram and bar chart. So bar charts basically have gaps, okay? They have gaps. Histogram, they are like together, okay? They have no gaps, they're together. Over here I have a bar chart, you see they have a gap here, but histograms do not have that, okay? And one thing you should know is that you will have such a curve in your graph. You do not have to add this curve, but this is just for reference, okay? Every time there's a continuous variation, you are going to draw a histogram, okay? Let's look into the discontinuous variation now. So in discontinuous variation, the only thing that contributes to variation is genes, okay? Only genes, all right? They have no intermediate, meaning that there is no extreme, okay? You won't have a range. It's just going to be your genes, that's it, okay? So example over here is ABO blood groups, seed shape, seed color, okay? ABO means A blood group or B blood group or O blood group, okay? So yeah, and over here in discontinuous variation, instead of making a histogram, you have to draw a bar chart, okay? Bar chart has these gaps, always remember this, okay? So just for reaching conclusion, your continuous variation would have extreme to extreme, which will be known as range, okay? Genes and environment contributes to this, and you would have to draw the graph in a histogram. And anything which is measured in scale is a continuous variation. And discontinuous variation, it's only genes. Draw a bar chart, and these are one of the examples. Next, let's look into mutations. So gene mutation is a random change in base sequence of DNA. In our previous chapter, we learned that DNA is made up of base sequence, and it kind of affects how our protein, our traits are formed, okay? So our base sequence determines the type of proteins we would have, and the proteins determine the type of trait we would have, okay? So mutation can cause your base sequence of DNA to change, okay? Your DNA would kind of like get interrupted, okay? And it will cause the base sequence to change, okay? New base sequence gives you new protein, which will give you a new trait, all right? Now mutation causes new alleles to form, okay? This is something in the inheritance chapter, which I think we have probably learned, okay? Or we are soon going to learn, so we can refer to that chapter later on. But mutation causes new allele to form, meaning that it causes new genes to be formed, okay? Allele is just an alternative form of the genes, okay? Next, okay, let's know the causes of mutation. So it could be some chemicals, or ionizing radiation. So ionizing radiation could be something like X-rays, okay, or it could be chemotherapy, something like that. All right, and you would have some chemicals. For example, over here there's already an example, which is tar. Okay, in your exam, if they ask you the cause of mutation, you can just write chemicals. You don't have to specify which chemical, you can just write chemical. Okay, and yeah, another thing which I forgot to look into is the sources of variation. So the sources of variation would be mutation, which we just went through. Meiosis. So meiosis is when two cells, okay, two reproductive cells, right? Reproductive cell, okay, this is your sperm, this is your egg, okay, when they meet each other and form one big cell, this is called meiosis. Okay, this is called meiosis. Or hold on, in proper words, this is a zygote. Okay, so meiosis forms this, meaning that you will have different traits, okay, different traits, and these traits would mix and give you a new trait. Okay, that's how this introduces new variation. And then there is random mating, which is related to meiosis, okay, and we have random fertilization, which is pretty much similar to meiosis, but you can use these examples. Okay, so that's pretty much it for the first chapter. The first part. I will be posting the rest of the chapter on the second part. Okay, that's pretty much it. If you liked my video, please make sure to like my video, okay, and please make sure to subscribe if you would like more content, more chapters, okay, and if you have any questions or suggestions, please comment down below. Thank you, that's pretty much it. Goodbye.